it says 1B, children, we are doing question number 1. Okay, define the term center of gravity of a body. Define the term center of gravity of a body. So now, what is the answer for it? Okay, the center of gravity of a body is a point. Please here, center of gravity of a body is a point on the body, 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 it can be outside the body also. So better don't use a word, is a point, just say is a point about which the resultant movements of force due to the weight of all the particles constituting the body is 0. So remember, beta, center of gravity of a body is a point about which the resultant movements of force due to the weight of all the particles constituting the body is 0. Okay, and very simple, but at the same time very important, children. You should know it. Okay. Yes, center of gravity. Can center of gravity of a body be situated outside the material? Give an example. I repeat, question number 2 says, can center of gravity of a body be situated outside the material? Give an example. So yes, center of gravity of a body can be situated outside the material, like material. Okay, the center of gravity example. They want one example. The center of gravity of a ring. Center of gravity of a ring is at the geometric center of the ring, which is outside, which lies outside the material of the, which lies outside the material of the ring, okay, children, very simple. Okay, now we go to question number 3. Question number 3 says, state factors on which the position of center of gravity of a body depends. Explain your answer with an example. State factor on which the position of center of gravity of a body depends. Explain your answer with an example. So I want to tell you one factor on which the position of center of gravity depends. The position of center of gravity of a body of given mass depends on the shape of the body, that is distribution of the mass. Okay, shape of the body depends on shape of the body. Got it? Now explain your answer with the help of an example. See, example, The center of gravity, the center of gravity of a metal wire, center of gravity of a metal piece of wire see, yeah, I'll change the language a little. The center of gravity, the center of gravity of a small piece, of a small piece of metal wire is at the midpoint, is at the midpoint of the wire. But when the same wire is bent in the form of a ring, the center of gravity becomes the geometric center of the ring. Center of ring. Hence, from the above example, it is very clear that center of gravity depends on shape of the body. Shape of the body. That is a distribution of mass, okay? That is a distribution of mass. So, we go to the next question now. Question number 4. What is the position of the center of gravity of a rectangular lamina? A. Rectangular lamina. B. Cylinder. What is the position of center of gravity of A. Rectangular lamina, B. Cylinder? So simple, beta. The position, the center of gravity, A का answer A part. The center of gravity of a rectangular lamina is the point of intersection of its diagonals, is the point of intersection of its diagonals, okay? Then the B part, the center of gravity of the cylinder, the center of gravity of a cylinder is the midpoint of the axis of cylinder, okay? Midpoint of the axis of cylinder. Then, at which point, now look question number 5, at which point is the center of gravity situated of triangular lamina? So same beta answer, A part, the center of gravity of a triangular lamina is the point of intersection of the medians, is the point of intersection of its medians is the point of intersection of its medians. Okay. Now, what is B? Of a circular lamina, the center of gravity of a circular lamina is the geometric center is a geometric center of the circular lamina of the circular lamina. We go to question number 6. Where is the center of gravity of a uniform circular ring situated? The center of gravity of a uniform circular ring is the geometric center. हाँ हाँ रे बाबा मेरा पूरा Where is the center of gravity of a uniform circular ring situated? Center of gravity of a uniform circular ring is the geometric center of the ring, which is outside the material of the ring. Okay. Now we go to the question number 7. Now, question number 7. Question number 7 says a square cardboard is suspended by passing a pin through a narrow hole at its one corner. Draw a diagram to show its rest position. In the diagram, mark the point of suspension by letter S and the center of gravity by letter G. So what I do, suppose this is it. Okay, I'm showing you the answer. I'm saying this is this point. Okay, this point. Ah, question number 7. A square cardboard is suspended by pin passing a pin through a narrow hole at its one corner. Draw a diagram to show its rest position. In the diagram, mark the points of suspension by letter S and the center of gravity by letter G. So naturally, I'm just showing you the answer. Suppose here, I will mark that pin. Pin is pierced to this point and this square cardboard is suspended on the wall. Got it? And it comes to rest in this position. So this is a point of suspension and this is the center of gravity. Remember always, whenever you suspend a particle, any body, okay, you'll always say it will come to rest in such a way that the center of gravity should lie below the point of suspension. So don't agree center of gravity lies below the point of suspension here. That means this diagram is right, okay, of ours. Okay, children? Now we go to the next question, children. The next question number 8, okay, question number 8. Yeah. Explain how will it determine experimentally the position of center of gravity for a triangular lamina or triangular piece of cardboard. Triangular lamina, triangular surface, or you can call it as a triangular piece of cardboard, okay? So what you do is, let me name it, okay? This experiment, okay? How I go about it. Here, let the three vertices of the triangular lamina lamina B, vertex A, B, vertex A, vertex B, and vertex C. Let the vertices of the triangular lamina be vertex A, vertex B, and vertex C. Okay. Make holes below each of these vertices. Okay. Make holes below each of these vertices. Now, suspender triangular lamina suspend the triangular lamina through vertex A at through vertex A by means of a nail. Okay. Also tie just 1 minute, children. I'll just say put it in proper wordings. Okay, it's very simple. See, Paila point, let the vertices of triangular lamina be vertex A, vertex B, and vertex C. Make holes below each of these vertices. Suspend the triangular lamina over a nail, over a nail, over a nail on the wall. Over a nail, suspend the triangular lamina over a nail on the wall through the node hole at vertex A. Vertex A. Tie a plumb line tie the thread of the thumb line, tie the thread of the plumb line on the nail and draw a line along the thread of the plumb line, thread of the plumb line. Okay. Tie the thread of plumb line on the nail, and draw a line along the thread of the plumb line at rest. The line bisects the opposite side. Opposite side. Similarly, repeat the same procedure to vertex B and vertex C. Point of intersection of these lines gives a center of gravity of triangular lamina. So I'll just read it, just like explain
How will you determine experimentally the position of center of gravity for a triangular lamina? Let the vertices of the triangular lamina be vertex A, vertex B, and vertex C. Make holes in each of the vertices. Suspend the triangular lamina over a nail on the wall through a hole at vertex A. Tie a thread of plumb line on the nail and draw a line along the thread of the plumb line at rest. The line bisects opposite side. Similarly, repeat the same procedure to vertex B and vertex C. And the point of intersection of these lines gives a center of gravity of triangular lamina. Okay, I hope people got me here. This is, I'll just show you by way of a diagram also here, a simple diagram, a simple diagram. Okay, this is my triangular lamina. This was my triangular lamina, and this was my vertex A and vertex B and vertex C. And I had asked you to draw that plumb line. Okay, so when we draw this, okay, state whether the following statements are true or false. The position, if first one, the position of center of gravity of the body remains unchanged even when the body is deformed. It is false. Okay, answer is false. Because when the body is deformed, the position of center of gravity changes. When a body is deformed, when the body is deformed, the position of the center of gravity changes because it depends on the distribution of mass, that is the shape of the distribution of mass on the shape of the body. Naturally, if it gets deformed, the shape has changed. Naturally, center of gravity will change. Next, second one, the center of gravity of a freely suspended body always lies vertically below the point of suspension. True. There is no reason for it. This is true. The point of center of gravity of a freely suspended body will always lie below the point of suspension. Okay. We go to question number